Welcome back. In our last video, we discovered Rust's ownership system, where each value has one owner and gets dropped when that owner goes out of scope. But what if we want to use data without taking ownership? That's where Rust's borrowing system comes in, and it is nothing short of magical. So today we are learning how to work with data efficiently without constant cloning or ownership transfers. This is where Rust truly shines with its zero cost abstractions. So today we will cover the references and the mutable versus immutable references, followed by the borrow checker rules. Then we will visit the dangling references prevention, and lastly practical borrowing patterns. So let's get dive into it. So let me give you a practical example on references. Let me create a file for the same references.rs fn name. Let s1 is equal to string from hello, and let len is equal to calculate length ampersand s1. Let's define this calculate length function ampersand string, which will return the size of the string as dot length. So whatever this will be returned, it will be stored in this len variable. Print ln the length of is s1 comma len. Let's execute. My bad, I added a semicolon here. References.exe spelling mistake. The length of hello is 5. So here, let me teach you what happened. So here the ampersand operator creates a reference of that variable. When I passed the ampersand s1 to the calculate length, it created a reference of this s1 string and passed it to the calculate length, and afterwards the length method actually worked on that string whose reference was passed as a parameter to the calculate length. This is known as the borrowing in Rust. Here we temporarily using the data that is originally existing in the memory. We are not copying from there. Hence this is called as borrowing. And after the computations, we are just giving the data back to the controller. This is how the references works in the Rust. Let's now uh, explore the mutable and immutable references. For the mutable reference, uh, you must create a reference on an mutable variable while the immutable reference points out to the immutable variable. So to explain it clearly, let me create a mutable string s is equal to string from hello. Let me comment it and define another function fn change some string ampersand mut string. Note that the sum string is going to take a reference of a mutable string. That's why the ampersand mut string type is given to it. Under this type sum string dot push str comma world. So the change method is doing it is taking some string and into it this will add an string comma world into the original string whatever is stored in this some string. Let's call this change function change ampersand muts println as after modification as oops, so got it as after modification is hello world, hence it worked fine in this case. The first example that I have shown in this case that I have already commented was already an example of immutable reference. So I'm just avoiding the another explanation for this. Let me teach you the borrow checker rules which is related to the mutable and immutable references. So let's check it out. So the borrow checker rule says that borrow checker rule that at any time you can either have one mutable reference or you can have multiple immutable references. This rule says means that at any point of time you cannot have both the mutable reference and immutable reference to a particular variable. At any point of time you can only have immutable references uh, and that can vary from one or more than one, while you can only have one mutable reference if you are not using the multiple immutable references. If you try to impose both the references at the same time, they just throw the compile time error. So that's why keep this rule in the mind. Second rule, however, is very common, which states that references must always points to a valid data, must always refer to a valid data. It means that it should not refer any. To be precise, second rule means that the references must always refer to a valid data. Valid data can be means that it should be existing. References must not be referring to a non-existing data, or there should not be a type mismatch. For example, the mutable reference might be referring to a immutable string, so that will violate the second rule. Or if the reference is referring to a variable which is holding a null value, that is also a is the violation of the second rule. In Rust, you can also use slices as the references. For that, you can proceed like this: slice ref.rs from name, let my string is equal to string from hello world, then let world is equal to first word ampersand my string, then define the first word method, colon ampersand str, ampersand str, let bytes is equal to s dot as bytes, for I ampersand item in bytes dot itr dot enumerate if item equal to little ampersand s 0 I, and lastly ampersand s. So the first word is actually extracting the first word in this string. If this string has multiple words separated by any space, then the first word, this function will extract the first word and return uh, from via here, and it will be stored in the word variable. So that's all it is done here. We checked through the for loop to extract the first word. Otherwise, if the original string is containing just only one word, then that entire string would be returned to the uh, here where the call is made to the first word. So through this way, the slice is being returned and is stored in the word variable. Now let me create a function for printing the slice. Slice ampersand I32 println slice. Now let's complete the main function. We have utility function at our hands now. First word, word. So this was an example uh, of a reference where the slice is actually working as a reference because the first word returned me a slice, and this slice is referring to this string hello world, which can we check by printing it here. Similarly, you can also uh, complete this example by working on the numbers as well. You can create a numbers array 1, 2, 3, 4, 5, and then create a slice ampersand numbers 1 to 4 and print slice. Here as well, the is slice on this numbers array is already working as a reference in this case. Let's execute it now. Rust C slice ref dot rs compiled successfully. Slice rf.exe. First word is hello and the slice on number is 234. Let me show you an example where the struct references are used. So let me create the file first of all. And here is the code snippet where the struct instances are actually used for the creation of references, and through that the values are either being read or being updated. So here is the struct named as user having these properties. First is username, second email, third is signing count, and last is active. And on this user struct, there is a get username method which is responsible for providing the username, and another is the increment sign in method whose job is to increment the sign in count, which is defined here. And the new keyword here is just creating a new user instance and returning it to the controller. Here is the main function where we are creating a new user and we are providing the name, username and email, etc. And the attributes which we are not passed here will automatically get default values from here, and the instances will be created on the basis of that. So when we will print the username, of the instance which is created here, the for executing the get username, the immutable reference is being borrowed for the reading of the username, and in the case of the uh, updating the value of the signing count, the mutable reference is being borrowed based on the user instance, which is actually a struct object. And afterwards, the updated sign-in count is being printed here. Let's execute this. Just see struct ref.rs .exe. Got the username Alice and sign-in count 2. This is the example of struct references where the references are made on an struct instance, and afterwards the username is read and mutable reference is being passed to the signing count variable from where the signing count value was updated. There are some common borrowing patterns. If you keep in your mind, then your life will be very easy while doing the Rust programming. Let me show you through the examples. So here is the code snippet. In this case, a mutable data is created, which is holding a vector having the values 1, 2, 3, 4, 5. And if you create a immutable borrow on this, like let first is equal to ampersand data 0, this is allowed. But if you try to data dot push 6, that is if you try to add some value into this, then this is the scenario of mutable borrow, and hence it will throw you an error because you are already have an immutable borrow already available and it is in the scope already. Hence, the mutable borrowing will not be allowed because of the first rule of the borrow checker rule. Hence, you will get an error. If you have to use the mutable borrow, you have to firstly invalidate the scope of the immutable borrow which you have created before that. You can limit the scope of that immutable borrow by printing it, by getting it printed, the first name immutable borrow. This will create the scenario where that immutable borrow will go out of scope, and hence your mutable borrow will work fine afterwards. Or either there is an alternative of the same handling for mutable and immutable borrowings. When you are working with the multiple data pieces, for example, the coordinate geometry where the x and y coordinates occur, and you store them as a tuple in your program. So there you can use the destructuring of the tuple to handle the borrowing scenarios. So in such cases, do not borrow the entire tuple like this. Instead of that, use the destructuring property on that from that tuple. go like this: ampersand point dot zero, comma ampersand mut point dot one. So here the first one is the immutable borrow and second is the mutable borrow, and both of them is get mapped to the x and y respectively, and afterwards you can update the value of the y and can check it via the println, and both of them will work fine. You will not get any error or named as the borrowing concerns. Other than this, you can limit the scopings of the individual coordinates which are already mapping to the immutable and mutable borrowings. However, the personally I like this way for the handling, for keeping both the immutable and mutable borrowings uh, in the scope cleverly without being fallen into the trap of borrowing errors. Let's recap the best practices now that we came across the entire tutorial. First is that at any time you can have either one mutable reference or the multiple immutable references. If you are reluctant to use both of them, you have to firstly uh, create a scenario where you can make one of them references go out of the scope so that you can use another, or either you can use the tuple destructuring to cleverly bypass the borrowing errors. And second one was the references must always be valid. No dangling references should be created. This will be checked on the compile time, and references have a lifetime. The borrow checker tracks that how long the created references uh, can live or when they have expired. Such execution flow of the references helps us to be away from the multiple bugs that can arise otherwise if these do not exist. In the next video, we will explore the Rust structs in depth, where we will create custom data types that can have methods and implement the traits. This is where we will start building more complex Rust applications, so stay tuned. You have now mastered one of Rust's most powerful features, which is actually the borrowing. Borrowing might be feeling you restrictive at first, but it is preventing the entire classes of bugs that otherwise you may get fall into, and it is already creating the havoc on the other programming languages. If you have any questions related to borrowing, drop them in the comments, and like and subscribe if this video helped you understand the Rust's most powerful feature, and I will see you in the next video. Thank you.